In this video, we are going to review some characteristics of polynomial functions. A polynomial function is defined as a function whose equation is defined by a polynomial in one variable. The general equation is given here. The degree of a function is the value of the highest exponent of the variable. If we are looking at this example here, this is a graph of f at x is equal to x cubed minus 7x squared plus 7x plus 15. The value of the highest exponent would be 3. The leading coefficient is the coefficient of the term with the highest exponent. Because our highest exponent comes with the term x cubed, in front the coefficient is 1. We would say the leading coefficient is 1. In terms of increasing, the graph rises when going from left to right along the x-axis. If we take a look at this graph here, it is increasing as we go left to right from negative infinity all the way up to 0.5, and then it also increases from 4 on. We would say then that the graph is rising for values of x less than 0.5 or x greater than 4. In terms of decreasing, as we're going left to right, our graph is decreasing from 0.5 to 4. We would say that it is decreasing then from 0.5 less than x less than 4. Turning point occurs when the function changes from increasing to decreasing. We have two possible turning points. One occurs when x is 0.5. The other occurs when x is 4. That is where our graphs are changing from increasing to decreasing. A local maximum or minimum is a point where the function changes from increasing to decreasing or decreasing to increasing. At 0.5, we would have a local maximum, and that happens when y is about 17. Our local minimum happens at 4, and our corresponding y value is negative 5. Our local maximum or minimum value is the y-coordinate of the local max or min. For the first point, our local maximum value would be 17, y equals 17. For our second point, our local minimum would be at y equals negative 5. Our zeros are also known as our roots or our x-intercepts on our graph. We have 3 of them. We have one at x equals negative 1. We have one more happening when x is 3. And our last one happens when x equals 5. End behavior is the behavior of the y values as x approaches positive infinity and as x approaches negative infinity. If we take a look at our graph, as x approaches positive infinity, our y values are also going to approach positive infinity. That is because as x is getting bigger, y is getting bigger. We would say then, as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, our y values also approach negative numbers. We would say x approaches negative infinity, then y also approaches negative infinity. The last characteristic that we're going to look at in this video are the finite differences. For a polynomial function of degree n, the nth differences are equal and they have the same sign, either positive or negative, as the leading coefficient. Now, because we have a degree of 3 for this function, that would mean that the third differences are going to be the same. They would all be constants then, and because our leading coefficient is positive, they would also be positive in value.